Hi, this is a video to give a quick introduction to my 8255 based IDE adapter for the RC2014 computer. This board allows you to use a wide variety of IDE storage devices with your RC2014, either in ROM WBW CPM or in your own C programs with Z88DK and FAT formatted partitions. 3.5-inch IDE drives are supported with the 40-pin connector, as well as 2.5-inch drives with the 44-pin connector. 2.5-inch laptop drives are particularly convenient due to their ability to be bus powered if you have a sufficiently powerful power supply. DOMs, Discom modules and solid-state IDE drives also work well. It's easy to construct, with no surface mount components, and all components are available new from the usual electronic suppliers. The board designs are open hardware, and the BOM, schematics and Gerbers are available in the GitHub repository, which I'll link below. We also have some PCBs available on Tindy. IDE devices were superseded by SATA in around 2003, but IDE drives are still widely available on eBay. In the UK, reconditioned IDE hard drives are available at CPC, with a 12-month guarantee. IDE was designed by Western Digital in 1986 and first appeared in compact computers the same year. IDE refers to the connectors, signalling and command protocols, as well as that the drive controller is integrated in the drive. The integrated controller presents an array of 512-byte blocks and a simple command interface to the host computer, whereas with older interfaces the host computer had to deal with the low-level details of the mechanical operation of the drive, such as positioning the drive heads. Looking at the board, you'll see there are only 3 ICs. The 8255 in its 8MHz CMOS PLCC 44 version, a 74HCT8688 comparator for address decoding, and a 74HCT04 inverter. You'll also see on the board there are some dip switches to change the base address of the board, an activity LED, and some jumpers to change which signals from the 8255 go through the inverter. This enables the board to be used for some of the more esoteric use cases of the 8255, such as controlling printers, floppy disk drives, or maybe machine tools. Finally, there is a jumper which connects the power pins on the RC2014's bus to the 44-pin IDE connector power pins. If your RC2014 power supply is insufficient to power a hard drive, there's also some pins to connect an external power supply. That's a brief overview of the board. I'll now get on to using it with ROM WBW. Okay, so this is my RC2014 setup that I use for CPM purposes. So it's got Scott Baker's 512K RAM-ROM board for running ROM WBW. It's got the floppy controller, SIO serial board, Z80 CPU, the slow clock board, my YM sound card, and obviously now we're going to add the IDE adapter to it. So previously we flashed the updated version of ROM WBW with PPIDE support to the EEPROM. So we've put that in there in the RAM-ROM board. And now for the IDE adapter, I've got the dip switches set to be at address of 20 hex. I've put all the jumpers in the default positions there, and I've also jumpered J5 here so that the power pins on the 44-pin IDE connector are powered from the bus power. So the drive that I'm going to be using in this demo is this Seagate Momentous drive, which is a 40 gig drive, which is obviously like massively overkill for CPM, considering that you can only have 8 megabyte partitions really. So I've got quite a long 44-pin IDE connector cable. I think this came from Full Speed IT on eBay for about £4. Okay, so I'll connect the drive to the IDE adapter. And then I'll stick it in this in one of these front slots. point the drive down there at the front. Cool. Okay, so we're ready to go. I'll connect up the serial to the SIO board. Okay, so now we're going to power on the RC2014. So as you can see, on first power on, the hard drive isn't detected. That's because the drive hasn't spun up yet. So if you just press reset, the drive's there detected as 40 gig hard drive. So if we proceed into CPM, we can then run fdisk and take a look at the drive in that. So for the purposes of this, the drive number is 4. Cool. And there you can see detected as a 37 gig drive, and it's saying that we've got a 4 gig FAT16 partition on there, which I think is from me messing around with in Z88DK. Okay, so we want to reserve some space at the beginning of the disk for CPM partitions, and then create a FAT16 partition after that. If we do initialize and then reserve, yes, so we want to reserve 8 CPM slices. So if we look at the partition table, now it should be empty. So let's create a new partition, partition 1, start there. We'll create a 4 gigabyte partition. Okay, so cool. Now we've got our reserved 8 CPM slices and then the FAT16 partition after it. So if we write that now, okay, that's now written to the disk. So as you saw previously, the CPM partitions started at drive letter E. So if we go to E and do a dir, you'll see you get this kind of weird output, and that's because we've not actually formatted the partition. So if we do clr E, and then it says, do you want to proceed, type Y to proceed, any other key to exit. This is actually case sensitive, so if I enter a capital Y, it says directory cleared. Cool. So if we now go to E and do a dir, it says there's no files on the disk. Anyway, I hope this has given you a bit of a introduction to using the IDE adapter with CPM. Okay, thank you very much. Cheers, bye.